Properties of water and vapor. So what is water? Water is an inorganic, transparent, tasteless, odorless, and nearly colorless chemical substance which is the main constituent of Earth's hydrosphere and the fluids of all non-living organisms, in which it acts as a solvent. It is vital for all known forms of life, even though it provides no calories or organic nutrients. Its chemical formula is H2O, meaning that each of its molecules contains one oxygen and two hydrogen atoms, connected by covalent bonds. Two hydrogen atoms are attached to one oxygen atom at an angle of 104.45 degrees. So these are the properties of water: cohesion, surface tension, adhesion, polarity, high specific heat, universal solvent, density, amphoteric, and vapor. First is cohesion. Water clings to polar molecules through hydrogen bonding. Cohesion refers to attraction to other water molecules. So water molecules have strong cohesive forces due to their ability to form hydrogen bonds with one another. Cohesive forces are responsible for surface tension. Water also has adhesive properties that allow it to stick to substances other than itself. These cohesive and adhesive properties are essential for fluid transport in many forms of life. For example, they allow nutrients to be transported to the top of a tree against the force of gravity. Surface tension, a measure of the force necessary to stretch or break the surface of a liquid, is related to cohesion. Water has a greater surface tension than most other liquids because hydrogen bonds among surface water molecules resist stretching or breaking the surface. Water behaves as if covered by an invisible film. Some animals can stand, walk, or run on water without breaking the surface. And this is seen in the figure. We have here an insect that is seem to be floating on the surface of the water, and the insect is not breaking the surface tension in the water. So water has a variety of unusual properties because of attractions between these polar molecules. The slightly negative regions of one molecule are attracted to the slightly positive regions of nearby molecules, forming a hydrogen bond. Each water molecule can form hydrogen bonds with up to four neighbors, and that's what we see here in the figure. Adhesion. Adhesion refers to attraction to other substances. Water is adhesive to any substance with which it can form hydrogen bonds. And that's what we see here in the image, where we have droplets of water on the surface of some leaves. Polarity of water. In a water molecule, two hydrogen atoms form single polar covalent bonds with an oxygen atom. Gives water more structure than other liquids. Because oxygen is more electronegative, the region around oxygen has a partial negative charge. The region near the two hydrogen atoms has a partial positive charge. A water molecule is a polar molecule with opposite ends of the molecule with opposite charges. High specific heat, amounts of heat that must be absorbed or expended to change the temperature of 1 g of a substance to 1 degree Celsius. Impact of water's high specific heat ranges from the level of the whole environment of Earth to that of individual organisms. A large body of water can absorb a large amount of heat from the sun in daytime and during the summer, while warming only a few degrees. At night and during the winter, the warm water will warm cooler air. Therefore, ocean temperature and coastal land areas have more stable temperatures than inland areas. The water that dominates the composition of biological organisms moderates changes in temperature better than if composed of a liquid with a lower specific heat. So the Earth is over 75% water. Universal solvent: a liquid that is a completely homogeneous mixture of two or more substances is called a solution. A sugar cube in a glass of water will eventually dissolve to form a uniform mixture of sugar and water. The dissolving agent is the solvent and the substance that is dissolved is the solute. Water is the solvent and sugar the solute. In an aqueous solution, water is the solvent. Water is not really a universal solvent, but it is very versatile because of the polarity of water molecules. So water is an effective solvent as it can form hydrogen bonds. Water clings to polar molecules causing them to be soluble in water. Hydrophilic means attracted to water. Water tends to exclude nonpolar molecules. Hydrophobic means repelled by water. So water transports molecules dissolved in it. Blood, a water-based solution, transports molecules of nutrients and waste organisms. Nutrients dissolved in water get transported through plants. Unicellular organisms that live in water absorb needed dissolved substances. So the density of water. So water is most dense at 4 degrees Celsius, contracts until 4 degrees Celsius, expands from 4 degrees Celsius to 0 degrees Celsius. And the density of water prevents water from freezing from the bottom up. Ice forms on the surface first. The freezing of the water releases heat to the water below, creating insulation, makes transition between seasons less abrupt. So oceans and lakes don't freeze solid because ice floats. Because water expands as it solidifies. Water reaches maximum density at 4 degrees Celsius, and water freezes from the top down, and organisms can still live in the water underneath the ice during winter. When water reaches 0 degrees Celsius, water becomes locked into a crystalline lattice with each molecule bonded to the maximum of four partners. As ice starts to melt, some of the hydrogen bonds break and some water molecules can slip closer together than they can while in the ice state. Ice is about 10% less dense than water at 4 degrees Celsius. So water is amphoteric, meaning that it can exhibit properties of an acid or a base, depending on the pH of the solution that it's in. It readily produces both H-positive and OH-negative ions. Related to its amphoteric character, it undergoes self-ionization. The product of the activities or approximate concentrations of H-positive and OH-negative is a constant, so their respective concentrations are inversely proportional to each other. Evaporation: each individual water molecule which transitions between a more associated liquid and a less associated vapor or gas state does so through the absorption or release of kinetic energy. The aggregate measurement of this kinetic energy transfer is defined as thermal energy and occurs only when there is differential in the temperature of the water molecule. Liquid water that becomes water vapor takes a parcel of heat with it, in a process called evaporative cooling. High heat of vaporization: amount of energy required to change 1 g of liquid water into a gas, 586 calories. Large number of hydrogen bonds broken when heat energy is applied. As a liquid evaporates, the surface of the liquid that remains behind cools. This is called evaporative cooling. Evaporative cooling moderates temperature in lakes and ponds and prevents terrestrial organisms from overheating. Evaporation of water from the leaves of plants or the skin of animals removes excess heat. Condensation: Water vapor will only condense into another surface when that surface is cooler than the dew point temperature, or when the water-vapor equilibrium in air has been exceeded. When water vapor condenses into a surface, a net warming occurs on that surface. The water molecule brings heat energy with it. In turn, the temperature of the atmosphere drops slightly and produces clouds, fog, and precipitation. So that's all for this topic, sir, and I hope you like the video and thank you for watching.